Alright, welcome to our lesson today on factoring special polynomials. Right? So a lot of times when you factor polynomials, you start to see some patterns here and there. And today we'll be working a lot with perfect squares. Our goals today, we'll learn to factor and expand some special polynomials and find their patterns, and understand the perfect square trinomials and the difference of squares formula. Right, those are the formulas you'll be seeing a lot on your formula sheets. So with that being said, let's just go over expanding a plus 2b squared. Right, so all we are doing here is doing a plus b times a plus b. And if we lay out just like a rectangle right diagram here, we have a times a in our first space, getting us a squared. In the second space, we have a times b. For this tile, we get ab. Same thing right here. A times b in this tile, we get ab. And lastly, b times b in this tile, we get b squared. Right? So a plus b times a plus b is just a squared plus ab plus b squared, getting us a squared plus 2ab plus b squared. So yeah, we can fully expand this right here. Right? So this is very arbitrary. As you might have noticed here, a squared and b squared, those are both perfect squares, right? Because no matter what number it is, so let's just pretend a is say 5, b is say 3, right? This means that this question right here will become 25 plus 2 times 5 plus 3, plus this is 30, and then plus b squared, that's 9, right? We notice that this number and this number, they're both perfect squares. And when we add them up in this hypothetical question, we get, let's see, 34, 64. This is the same thing as if we just did 5 plus 3 squared, which is a squared, which is 64. Right? So this is just a shorthand way of dealing with this pattern. And in practice, this is what it will look like. So in those examples, we notice that this right here, 4x squared, is a perfect square. And this 9 here is also a perfect square. Right? A quick reminder, a perfect square is just any number that can be square rooted. So with that being said, right, well, actually I'll write this formula in bold here. Right? So this is a very important formula to know. And we can notice something here. The first term must be a perfect square. The second term must also be a perfect square. And the middle term here, right, is just 2 times the square root of the first number times the square root of the second number. Okay? So let's check it out. 4x squared, the square root of that. If 4x squared, if a squared in this case is 4x squared, then a is just 2x. Similarly, if b squared is 9, then b is just a square root, which is 3. And now 2ab in this case just means 2 times 2x times 3, which is 12x, right? Which is exactly what we have in the middle here. Which means that to factor this, instead of doing the whole guess and check method, right, we could easily do the whole, 1, 4, 1, 9, crisscross this. This is 9x plus 4x, we get 13x, that's not correct, let's keep guessing, right? Instead of doing the whole guess and check method, we can immediately notice that we have perfect square. When we square root it to get 2x and 3, when we multiply this by 2, we get the middle number right here. Right, so instead of laying out the whole guess and check, we can just simply do, that's just 2x, the square root of 4x squared, plus 3, the square root of 9. Right, it's like a really quick way to factor something. Right, and once again, we can also just do 2x here, 2x here. We cross with a 3 and a 3. Right, when we do the guess and check method, we get 6x plus 6x, which is 12x. 12x, which is in the middle. Which means that we can just write this out as 2x plus 3 times 2x plus 3. Right? So if you notice a question like this, there's nothing wrong with using the typical guess and check method or decomposition method. It will just be a lot faster if we can recognize right away that there are perfect squares in them. Alright, so now let's try another example here. Well, once again, we notice that this is a perfect square. This is a perfect square. But the tricky part is we have a negative sign in the middle here, right? So let's worry about that later. But first of all, let's see, the square root of the first number, right? So if a squared, or if the first number here is 4, then a in this case will be the square root, which is 2. Now for b, if b squared is 25x squared, then the square root of that is just 5x. Okay? And then we can confirm this. 2ab would be 2 times 5x, getting us 20x. Alright, so this works, right? We can use our quick factoring method. Alright, so this right here is called a perfect square trinomial. We notice that we actually get a positive 20x, not a negative 20x, like we're supposed to here. So all we have to do is change to a negative sign. So instead of 2 plus 5x, we get 2 minus 5x squared. Right, so all we're working with is just square rooting. Okay, let's do another one. 16, perfect square. 49, a squared is also perfect square. Alright, so we notice the square root of 16 is 4, which is a. The square root of 49a squared is 7a. That is so confusing. b is 7a, okay? So right here, we can double check. 2 times 4 times 7a gets us 56a, right? It's positive 56a, which is still okay. Because all we have to do is have 4 subtract 7a to get 4 minus 7a squared. Alright, so just like that. Okay, let's try another special method here, or the special factorization. So this right here is the difference of squares. So when we factor something like this, a squared minus b squared, right, we're taking this shape here. So this square doesn't look like a square, but that's a square. Right, this square right here has an area of a times a. If we were to take away a chunk of b times b here, right, if we were to take away this chunk, let's actually color it so it looks nice. Right, so if we are to take away this chunk here, what we are left with, if we arrange the shapes, is that we can put this, oh, that's the pen here. Right, so now what we are left with here, when we rearrange all the shapes, right, what we are left with is this green area now. Because we took a chunk of b away, this green area has now the length of a minus b. Okay? And now this yellow area, this length is just b by itself. Right? So again, b by itself. And now the length, right? The length of all of them, as you can see when we put them all together, is also a minus b. So now when we add all of this together, right? We have a minus b plus b plus b, we get a plus b. Which means that when we factor a squared minus b squared, all we get is a plus b times a minus b, right? And this is, again, another formula that you should memorize, or will be given to you on the formula sheet. And this is the exact reason why, right? So once again, we take this perfectly nice square of a squared, we take away this chunk of b squared here, and now we're left with segment 1, segment 2, segment 3. And now when we place them together in a rectangle shape, we get this green square of the height and the length of a minus b. Because once again, a is the long side, we take away from the b, so it's just a minus b. And then we have those two squares, or rectangles, with the width of just b, right? As you can see here, this is the rectangle's width right here. When we add this bottom length up, we get a plus b. And this height has always been a minus b, right? Because it's the square's default length. And yeah, that's all there is to it. So now in practice, we notice that we have two perfect squares here again. 25 and the 36x squared. The square root of 25 is 5. Square root of 36x squared, 6x. So all we're doing here is just taking the square root of both numbers, subtracting them. So all we're doing here is taking the square root of both numbers here, right? And then we first add them up together, 5 plus 6x, and then we subtract them. That's all there is to it. We're just taking the square root of those numbers. Okay, so I should write this formula down again. So right, so once again, with those variables, all they're telling us is that those are just any numbers, right? But they all have to be perfect squares. So, down the next question here, 5 and 80, they aren't exactly perfect squares. But we notice something interesting. Right, we can take out a 5. We can factor a 5 from both of them, right? So going back to what we learned about common factors, we factor out the 5, we get x to the power of 4. 80 divided by 5 is 1, 6. And conveniently, we get something like this, where this right here, x to the power of 4, that's a perfect square. And this right here, 16, y to the power of 4, is also perfect. So now, it's all in brackets now. So the square root of x to the power of 4 is just x to the power of 2. Square root of this is 4 times y squared. So this means that we have x squared plus 4y and then x squared minus 4y squared. Okay, but wait, there's more. We notice here again that x squared, once again, is still a perfect square. 4y squared is still a perfect square, so we can keep going with this. Right, the square root of x squared is x, the square root of 4y squared is 2y. Okay, so once again, we can factor this even further. This becomes x plus 2y times x minus 2y. That was an absolute doozy, right? Quite a difficulty jump. But the principles we're using is exactly the same. Now let's try another one. 162 and 2. Obviously not perfect squares. So what we can do is factor out the 2 out of them. So 162 divided by 2 is 81. We got a v to the power 4 minus w to the power 4. Once again, very convenient. We got perfect square, perfect square. Okay, the square root of 81v to the 4 is 9v squared. Square root of w4 is w squared. Okay, this means we have 9v squared. You can probably see where I'm going with this, right? Plus w squared. And no, would you look at that? Once again, we can keep using the same formula. Except this time, I don't know if I have space. So 9v squared, square rooted is 3v. W squared square rooted is just plainly w. This gets us 3v plus w times 3v minus w times 9v squared plus wv. Right, here's another common mistake that I see here and there. The reason why I'm not factoring this any further is because there's a plus right here. Alright, this formula right here, the a squared minus b squared, this only works if there's a negative sign in the middle. The plus sign, unfortunately, doesn't work. Okay, with that being said, so using this formula here and using this formula here, let's do some exercises. Right, so pause the video, do the exercises, and see how you do. Okay, so hopefully you got some practice in. Let's get to the answers. We notice that we have a 9 here and a 25 n squared, both of which are perfect squares. So we use the first formula. Actually, let's write the formulas down. So in this case, we have 9. So the square root of 9 is 3. The square root of 25 n squared is 5n. We notice that 2 times 3 times 5n is 30n. So this formula will apply, meaning that this right here is just 3 plus 5n. Okay, next one. We see perfect square here, and a minus sign right there in the middle, which means I will apply this formula up here. So the square root of 9d squared is 3d. Square root of 16f squared is 4f. We'll factor this to 3d minus 4f squared. Next, right here, we don't see any perfect squares, but not a problem. We can, first of all, divide everything by -2, right? Or factor out the -2 here, right? Which means we have -2 out. We get a positive 9b squared minus a, 64c squared. And once again, very, very convenient, right? So from here, we notice perfect square, and a minus in the middle. So we can use this formula again up there. So we have minus 2, 3b plus 8c times 3b minus 8c. This time, no need to keep going because there's no more perfect square. Right? So for the last question, as we can see, no perfect squares in sight. But we can factor out 2. Right? If we divide everything by 2 here, so remember everything stays in a bracket, minus 20pq plus 25. Conveniently, we see 2 perfect squares pop up here and here. Alright, so we'll be using this formula here because we see that there's a negative sign. Right, so the square root of 4p is just 2p, or the square root of 25q squared is 5q. Using the formula above, but keeping the 2 in a bracket, we have 2p minus 5q. Alright, so there we have it. Once again, all those questions are completely possible with the guess and check method, the crisscross, and the decomposition method. But the main advantage of those formulas up here is that we can just skip all the guessing and stuff and just straight up use the formula. So once again, those formulas only work if those specific terms are perfect squares. Right? And in the cases of the perfect square trinomial formulas, this will only work if this middle number, so this middle number here, equates to 2 times the square root of the first and the last string. So yeah, that's pretty much it. So keep practicing and stay hydrated.